You ever look at a bunch of data, just a pile of raw numbers, and feel like there's a story hiding in there somewhere, but you can't quite see it? Well, today we're going to learn how to find that story. We're going to use an awesome tool called Cross-Tabulation. Let's dive in. Every great data analysis starts with a great question. So here's the one we're going to tackle today. Is there a connection between a student's gender and whether they prefer to learn online or in person? This is our mystery, and we're going to solve it together. So, what's our secret weapon for this? It's called a cross-tabulation, or you might hear it called a contingency table. Now, don't let the fancy name fool you. It's really just a simple grid, a table, that's designed to do one thing incredibly well: help us see the relationship between two different things, two variables, like gender and learning preference. Okay, first things first, we have to take all our survey answers, this jumble of raw data, and bring some order to the chaos. We're going to build our table from scratch and turn those messy numbers into something we can actually work with. Here's our blank canvas. See? Just a simple 2x2 grid. On the side, we have our rows, and that's going to be our first variable, gender, split into male and female. Then, across the top, we have our columns for our second variable, learning preference, which is online and in person. Each of these empty boxes is about to tell us a little piece of the story. And now, let's plug in the numbers. Let's imagine we surveyed 200 students, and this is what we found. That 30 in the top left, that means 30 students are both male and prefer online learning. And the 50 down in the bottom right, that's 50 students who are female and prefer in person. Each number, what we call a cell count, shows us where those two categories overlap. To really complete the picture, we need to add up the totals. So if we add across the rows, we can see we surveyed 100 male students and 100 female students. Those are our row totals. And if we add down the columns, we find that 80 students in total prefer online and 120 prefer in person. And look, in the bottom right corner, everything adds up to our grand total of 200 students. Perfect. Okay, now stop. This is a super important moment. Our table looks nice and organized, but these raw numbers, they can be really misleading. You might look at this and think, hey, 70 men prefer in-person, but only 50 women do, so men must like it more, right? Well, not so fast. To find the real story, we have to dig a little deeper than these simple counts. And this is where the magic really happens. It's all about percentages. Percentages are the absolute key to unlocking the story in our data, because they let us make fair comparisons. To get the full picture, we're going to look at our data from two essential angles, using row percentages and column percentages. Let's start with row percentages. This calculation answers a very specific question. Within each gender group, what's the preference? We're looking at the men and women separately. The formula couldn't be simpler. You just take the number in any box, divide it by the total for that row, and then multiply by 100 to get the percentage. Okay, let's focus just on the male row. The total number of men is 100. So to find the percentage who prefer online, we take the 30 men in that box and divide by the row total of 100. That's 30%. For in-person, we take the 70 and divide by 100, which gives us 70%. And notice, 30% plus 70%, that's 100% of the male students accounted for. Now let's do the exact same thing for the female row. Again, the row total is 100, which makes the math pretty easy. We take 50 divided by 100, which gives us 50% who prefer online, and the other 50 divided by 100 is, you guessed it, 50% who prefer in person. And again, 50 plus 50 gives us 100% of the female students. All right, now we're going to flip our perspective completely. Let's talk about column percentages. This answers a totally different question. We're no longer looking within a gender. We're now asking, of all the people who prefer online, what percentage are men and what percentage are women? The formula is almost the same, but this time we divide by the column total. So let's zoom in on the online column. The total for this column is 80. So of these 80 online learners, what percentage are male? We take the 30 male students, divide by the column total of 80, and we get 37.5%. For females, we take 50 and divide by 80, which comes out to 62.5%. So this tells us that the group of online learners is mostly female. And let's finish up with the in-person column. The total here is 120 students. So, of these 120 people, how many are male? That's 70 divided by 120, which is 58.3%. And for females, it's 50 divided by 120, which gives us 41.7%.
And once again, those two percentages add up to 100% of that in-person group. Okay, so we've got all these different percentages floating around. We have row percentages, we have column percentages, but which one do we actually use? Which one answers our original question about the connection between gender and learning preference? This is probably the most important step of the whole process. Look at the difference here. This is so crucial. Our original question was about how gender influences preference. The row percentage, which asks what percentage of men prefer in person, gets right at that. It lets us compare the preferences within each gender group. The column percentage, on the other hand, answers a totally different question. So to find the relationship we're looking for, we have to use the row percentages.
So we've done the math, we've picked the right perspective, and now, finally, we are ready to pull back the curtain and reveal the story that our data has been waiting to tell us all along.
And boom, here's our answer in a simple chart. By comparing the correct percentages, our row percentages, the pattern just pops right out. We can clearly see that 70% of male students prefer in-person learning compared to only 50% of female students. So based on our data, yes, there is a connection. Male students in our survey showed a stronger preference for in-person learning than the female students did.
So what's the big takeaway here? Let's break it down into a simple toolkit. 1. Always start with a clear question. 2. Get that raw data organized into a table. 3, and this is the most important part, use percentages to find the real story. Don't get fooled by raw counts. And 4, compare the right percentages between your groups to finally answer your question. You now have this powerful new lens for looking at the world. Seriously. From why people buy certain products to social trends, these relationships between categories are everywhere, just hiding under the surface. So the only real question left is, what patterns are waiting to be discovered in the data you see every single day?